In this video, we're going to work with the sine, sum, and difference formulas, these two right here. In our first example, it says find the exact value for the sine of 7 pi twelfths. I've made a list of my angles from 0 radians to pi radians. Just to keep it here as a reference, they're in increasing order. And from our previous video, we said that finding the exact value means no decimals. I need to keep the values and the answers in their original form. If they're in a fraction, keep them as a fraction. If you end up with square roots, you keep the square roots. So 7 pi twelfths is not a special angle that I know of from the unit circle whose value I know. So I need to rewrite 7 pi twelfths in a way that I can solve it. Okay, and what we're going to do is we're going to look at our special angles, look at the denominators. None of them are 12, but I need to find denominators that will make 12 if I multiply them together. So to make 12, I can multiply this denominator of 6 with this denominator of 2. That's one option. I can also do 4 and 3. That makes 12 also. Or I can do 3 and 4 here, or this 6 and this 2, and there are many options. I like to keep it in the first quadrant. It's easier for the signs. So I'm going to try and make 12 using pi 6 and pi halves and see if that works out. Here's what you do. You take pi 6 and you add it to pi halves. I'm adding, not subtracting, because I have small values here. I'm going to check to see if I can add and make a 7. Now, you know that when we add fractions, we need to have the same denominator. So I need to look for a common denominator, and I already know it's 12 because that's what I'm trying to get to. That's why I combined 6 and 2, because when I multiply 6 times 2, I'll get 12. So to make pi 6 into something twelfths, I need to multiply the numerator and the denominator by 2. So this becomes 2 pi over 12. And I do the same thing on the other fraction. To make this 2 a 12, I would have to multiply 6 over 6, and this makes 6 pi over 12. So now I have 2 pi twelfths plus 6 pi twelfths. That makes 8 pi twelfths. I need 7 pi twelfths, not 8 pi twelfths. So these two angles that I grabbed from my list do not work. So I'm going to try another pair. I'm going to try 4 and 3. So I'm going to take pi fourths. I'm going to add pi thirds. And again, I'm going to look for a common denominator, which is 12. I already knew that. So to make 4 into 12, I multiply 3 over 3. To make 3 into 12, I multiply 4 over 4. I end up with 3 pi over 12 plus 4 pi over 12. And that gives me 7 pi over 12, which is exactly what I need. So I found the two angles, special angles in my unit circle, that I can use to rewrite 7 pi twelfths, and I've checked it, and I do get 7 pi twelfths. So that means I can rewrite this expression as the sine. I split 7 pi twelfths up into a sum of pi fourths plus pi thirds. Okay? And now that I did that, I can use the sine sum formula. This one right here, the sine of u plus v, which is what I have here, the sine of u plus v. This is your u, this is your v. And it says that this will equal, let's write equals, this will equal the sine of u times the cosine of v. So this will equal the sine of pi fourths times the cosine of pi thirds. And then it says plus, so plus, and then cosine u times the sine of v. That means cosine of pi fourths, because that's u, times the sine of v, which is pi thirds. And there you have it. Now I'm able to simplify these expressions, and this will equal the sine of pi fourths, that's the square root of 2 over 2, times cosine of pi thirds, that's 1/2, plus cosine of pi fourths, square root of 2 over 2, times the sine of pi thirds, which is the square root of 3 over 2. And again, I multiply these two together and I get square root of 2 over 4. And here I get square root of 6 over 4. And your final answer looks like the square root of 2 plus the square root of 6, everything over 4. For example 2, let's find the sine of pi twelfths. I'm using twelfths again, but now it's pi twelfths, and I need to figure out how to combine two angles that I know of so that I can get pi twelfths. So I'm going to try a subtraction now. So I'm going to try and rewrite this as the sine of a subtraction. Okay? So since I need twelfths, I need to combine 6 and 2, that makes 12, or 4 and 3, that makes 12. So let's try let's try pi halves minus pi 6. So I'm going to take pi halves minus pi 6, and I'm subtracting because I'm going to get a small value. Pi halves minus pi 6, I need a common denominator, so 6 over 6 on this side, 2 over 2 on this side. That's going to give you 6 pi twelfths minus 2 pi twelfths. And that gives you 4 pi twelfths, and that will be pi thirds. So I don't get pi twelfths. Let's try the other combination. Let's remove this. The other combination I can try is 4 and 3. So let's try pi thirds minus pi fourths. Common denominator, I have to multiply by 3 over 3 on this side and by 4 over 4 on the other side so that I get 12 in my denominator. That gives you 4 pi over 12 minus 3 pi over 12, and there I get pi twelfths, which is what I needed for my expression. So I have found the pair that I can split pi twelfths into. I can split pi twelfths into pi thirds minus pi fourths, which are two special angles that I know the value of. So pi thirds minus pi fourths. Okay? So now that I have rewritten the pi twelfths into a difference, now I can use the sign of a difference. The sine of u minus v is sine u cosine v. So remember, this is u, this is v, and it says it equals the sine of u, which is pi thirds, times the cosine of v, which is pi fourths. And then we have minus, and then we have cosine u sine v, cosine of u, which is pi thirds, times the sine of v, which is pi fourths. Okay, and now we simplify. And this will equal square root of 3 over 2 times the cosine of pi fourths, that's the square root of 2 over 2, minus the cosine of pi thirds, that's 1/2, times sine of pi fourths, square root of 2 over 2. So this is the square root of 6 over 4 minus square root of 2 over 4. That means square root of 6 minus the square root of 2, everything over 4, and that is your final answer. In our next video, we're going to do tangent. I'll see you there.